next one is to start doing some assembly language, which we've seen a little bit of it go by in the debugger, but here you'll learn a little more. And I had a lot of students that were confused about assembly language, and I was real pleased to learn about this Jasmine product, which is a Java-based x86 simulator. So you can make a new file, and it runs on any machine with Java. I'm running it here on a Mac in Java, which is extremely slow, which I think is pretty normal for Java. It did eventually respond before, so I'm hoping it will listen to me say new. It does eventually respond to new file. You just have to like count to 10 after each significant operation, which is pretty normal. And now you can learn how to write assembly code. For example, you can move EAX, 1. All right. And I got to have EAX. All right. It turns green when you make it. Now I think I can make the font bigger, which is the, but when I hit configuration, I'm going to have to apparently count to 10 for it to notice that I've done that. Okay. All right. And it used to be faster, but Java is always pretty horrible, as anybody will tell you. I was going to take it to Lucida, if I could find it. There's Lucida. And 16 is fine. Let's see if that does any good. Is there a save somewhere? Doesn't seem to be a save anywhere. Okay. Tab, maybe that takes effect. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. And it is bigger indeed. All right, so if I move EAX, 1, here are the registers, which are memory stored on the processor, EAX, B, C, and DX. Those are the all-purpose registers. So if I execute that one command, which is here, it will then put a 1 in EAX. All right. Now I can move EBX 2 and execute that. And it didn't like it because I had a comma in the wrong place. So now it tells me, it gives you it explains the command down here. So I can reset everything and move through those instructions. There's the first one and the second one. Now I can put them in the stack with push EAX and push EBX. All right, and when I do that, when I push EAX, nothing seems to happen, but that's because memory is over here. And if I go to the bottom, that's where memory is. And let me rearrange the size of my window. There, you see it put, what it did was it took the 32-bit value 1 and pushed it into memory. And when I push the next one, it pushes the next 32-bit value 2 into memory. And so it's loading in memory. Now when I pop them off of there, I can pop into ECX and pop into EDX. And when I do that, it's going to take them out of the stack and put them in the registers. So that goes into there and there. So they come off in reverse order. Notice they do not erase from memory, which is a vulnerability we've been talking about off and on here. Data is left in memory that you're done using. It's not erased. So there are a bunch of memory corruption exploits that exploit this fact. And there's one I demonstrated at Hope years ago where you can steal passwords right out of RAM. From browsers at that time, they would just leave your password in memory instead of clearing it out. They've mostly been fixed since then. But anyway, that's data remnants. And so you can learn the basics of assembly language programming here in this simple little environment. And it's really pretty nice. And so I have a couple of challenges here. You can learn how to write the code and practice it. And there's even one where you have code that will draw something on the terminal and then erase it. You have to run the program halfway through and pause it at the point where you can read the magic word. So anyway, this is a place to get started with assembly language programming. And the way to really do it is, of course, OllyDbg, which is what I said before. OllyDbg is your best friend. And we've already got the putty.exe in here. So let's just move into the real OllyDbg messing with exe. If you haven't done this, this is a good way to get started. So let me get rid of that. All right, so first I verify the hash of my putty, which is here. I'm going to get rid of these extra modified versions of putty we made before. And so if I verify the hash of that putty, it starts with 9F9, and that is correct. So this is the version I wanted to work with. And so now we already know it runs, but we're going to go a little further than before. So when I run it, I can give it the name of a server here, like one of mine, ad.samsclass.info, and then click open, and it will ask me a question, and I'll just say yes. And now it shows me this message, login as. That's as far as I want to go. I don't plan to use any more functionality in the program. I want to mess with that message. So I'm going to close this, and now we can do it in Olly. So let's bring up OllyDbg, which we've got in downloads. And get rid of all the irritating complaints. All right, and so I run putty in OllyDbg. All right, and here it shows me the instructions that are going to launch putty, which we've seen before. And now I run it. Now notice it says paused here. When it loads in a debugger, the program is not running. It's just sitting there waiting for more instructions. And so if I want to find the code that prints that login message. So the way to do it in OllyDbg is you right-click here and search for all referenced text strings. And this will find not just strings, which are a series of bytes that are readable. It's going to find strings that are referenced by address in some instruction. So strings that are used in some kind of function call. And so I can now find, edit find, search find or something, Control F. All right, where's the find? Search for text. Right-click, search for text, okay? Right-click, search for text. There we go. Login as. All right. And it didn't find it. And probably because it's only looking down, not up. Let me try going to the top. See if that works. There's various things that can go wrong here. Right-click, search for text. Okay. Now it found ASCII login as. Okay, and I'm going to press F2 to put a breakpoint here, and then I'm going to find again, because there's two of them. So I'm going to put breakpoints at both of them, at the push instructions that use them, and now when I run the program, it will stop when it hits the one that I'm using. So I can go to CPU and run it, and putty opens up. Now I put in the name of a server, and say open, and now it hit it and broke. It was just about to print login as, and it stopped. So this is where the actual instruction that I want to mess with exists, the one that prints the string login as. So it's 41C B6E, which I've got on one of these screens. 41, yep, that's it. 41C B6E. So I've got a record of it. So now I'm going to alter that message. So first I'm going to clear the breakpoints, which I think I can do. Yeah, view breakpoints. And now I can delete them. Okay, so now it's not going to do any more of that breaking. and I'm here. So if I just wanted to change the message with one character, I could right-click and follow in dump immediate constant, and it will take this address referenced right here. 68 is the push. The rest of this is the address in little endian order, 0046 7C 7C, which is here. There's the actual data stored there, and that is the string login as. So if I change this byte right here to 7D, it'll point to the O instead of the L. And I can do that by hitting the space bar here to assemble, or right-click assemble, which is the same thing. And I can put in push 467C 7C. I can change the last letter to D and assemble that and cancel because I'm done. And you see it changed that one command to here, and 7D is going to point to the O instead of the L. So I've now created a modified version of this program, and all I have to do is save it. So I right-click here, and I copy to executable all modifications. And I got to warn you about OllyDbg. When you copy all modifications, you are not getting all modifications. It's lying. You're only getting all modifications made in that memory segment. So if you were to change things in the executable code, which is the text segment, and also in the data, which is either the data or the RData segment, and save it, you would not get both changes. That took me a long time to learn. I was very frustrated. Copy all. The best thing is save it after every change. Now I can right-click and save file, and downloads is all right. I'll call it putty2. Okay, so I've now made a file called putty2. I'm going to close Olly and go in my downloads and find putty2 and run it and give it the name of a server. And now it printed login as without the L. So I made a modified version of the file that printed something different. Now I could I could modify this one again. Let me just start up Olly again, which is here. And I'll do the other thing which I mentioned. Let's get rid of all the complaining messages. And if I might as well start, I'll start from the genuine putty. And then I can right-click, go to expression, and I can put in that address for, that's the one, 41CB6E. 41CB6E. That will get me to this place. Nope. I've spelled it wrong. 41C. Okay. So here's that instruction. So instead of changing this instruction, I could be changing the text down there. So I follow immediate constant. Okay, now I could modify this text down here. There. I could edit this. Binary edit. Okay, and now I could change it to say darkness. And say OK. Now that text is changed. Now to save it, I have to right-click down here and copy to executable. And right-click save file. And I'll call that one putty3. And if I've done it correctly, that one will print darkness. Putty3. And it does. The prompt is now darkness. So you can make a few modified versions of a file here, and it's a good way to learn how to use putty. And there are some more challenges down here too, including a game, which is good, clean fun. This is one I got from, I think, EasyCTF. And let me just talk about one of these because it's really quite educational. Copy link address. Let's close all this and go here. All right. So this is a command line password guessing game. So I go to downloads. Okay. There's a thing called 000. So if I run that, it asks me for something. If I give it an answer, it insults me, saying my dog figured it out before you. There is presumably a correct password I could use, and I could use strings to find the password, or I could use a variety of techniques. But the thing I want to do is cheat on the game with Olly. So let's run Olly. Because the great thing about this game is so simple you can easily read the whole game in assembler. So I go to downloads, I find 000 and load it. Okay, and now if I make this pane bigger, you can actually read this pretty easily. And I'm going to move this over this way. There, that should work. All right. Now notice what's going on here. This is why this is really cool. Over here, it tries to help me. It calls the system call putS with that string. This prints the prompt. This reads from the user. This one is what you get if you got it right. Wow, you got it right or something. And here's where I think my dog figured it out. And that's the end. The whole program fits in just about one screen of Olly. So we can totally figure out how to cheat. Here it prints out the prompt. Here it reads something from the user. Then it does some kind of moving data around. Then it calls a compare command. And then it calls a jump not zero. This comparison decides whether you got the password right. And this jump jumps past this one down to 40205A down here. It prints out the message that you failed. So if I just don't do the compare and I don't do the jump, then it will always take anything as right. So all I have to do is right-click, assemble, and fill with NOPs, and put in NOP here. Assemble. And it will take all those instructions and replace them with NOP, which does nothing. And now I want to get rid of the jump the same way. So I just click assemble a few more times. Now I click it one more time, and it fills that with NOPs. Now I'm done. Now I just need to save this game, and I've made a game that will always accept any response as correct. So I copy to executable, all modifications, copy all, right-click, save file, and I'm going to put it in the downloads folder, and I'm going to call it 000 mod. That's my modified game. And now if I go find my command prompt, and go to downloads and do a directory, there's a modified game. So if I run the modified game and I give it the same answer, now I'm correct. And I get a prize, which is one letter. So that's pretty cool. And it's a very nice way to practice patching binaries and understanding how they work. And there's a series of challenges here where you have to patch more and more of them. The original one from, I think, EasyCTF, you had to patch 67,000 of them, and then you got a bunch of JSFuck, which is this incredibly obfuscated JavaScript language you have to, and you had to patch errors in that. Took a long time. Anyway, that's another way to practice reading some assembler and modifying it. So those are good way to get introduced into a little bit of assembly language programming.